Hello everyone, my name is Muhammad Al-Muhtasib. Today I will be explaining the topic time value of money. First, I will start with the definition of time value of money. Then I will discuss and compare between future value and present value. Then to define what are annuities, the two types of mixed stream and cash flows. Finally, how to calculate loan amortization. Time value of money is the benefit of receiving money now than later. It is based on the time preference. This explains why we pay or earn interest whether we invest or make a deposit or take a debt or a loan. It also helps investors to determine whether to make an investment now on a specific project and expect a certain amount to be received in the future. Future value is the value of a current investment of assets at a specific time in the future with the specific interest rate found by applying compounding interest. And the formula of the future value is FV equals PV, which is the present value, multiplied by the sum of 1 plus R, which is the annual interest rate, to the power of N, which is the period of time, usually in years. An example given: if you deposit $800 at a rate of 4% annually, how much money will you have at the end of 5 years? We apply these numbers to the formula. So FV equals $800 multiplied by 1 plus 4%, which is the interest rate, to the power of 5, which is 5 years, and we get $973.32. Present value is the current value of a future sum of money or streams of cash flows. We discount future cash flows to find the present value. And the formula of the present value, PV, equals future value divided by 1 plus R to the power of N. An example given: how much should you pay now if you have the opportunity to receive $500 in 1 year if you can earn 7% on your investment? So we apply these numbers to the formula. So PV equals 500, which is the future value, divided by the sum of 1 plus 7%, which is the interest rate, to the power of N, which is 1 year, and we get $467.28. Annuities, they are payments made at equal periodic phases or intervals, and they can be cash inflows or outflows. And also we have two types of annuities. The first one is ordinary or deferred annuities, which means cash flows happen at the end of the period. And the other one is annuity due, which means cash flows happen at the beginning of the period. And these two annuities differ in time of cash flow. And now I will explain future value and present value in both types. First, future value of ordinary annuity. The formula is future value equals cash flow multiplied by the sum of 1 plus R, which is the interest rate, to the power of N minus 1, all of these divided by R. An example given: how much money will you earn at the end of 3 years if you deposit $1,000 and choose ordinary annuity and 5% earned annually? We apply these numbers to the formula. Future value equals 1,000 between brackets 1 plus 5%, which is the interest rate, to the power of 3 because it's 3 years, minus 1. All of these divided by 5%, which is the interest rate, and we get $3,152.50. The second one is future value of annuity due, and the formula is future value equals cash flow multiplied by 1 plus R to the power of N minus 1 divided by R, all of these multiplied by 1 plus R. An example given: future value equals 1,000, which is the cash flow, multiplied by 1 plus 5% to the power of 3 minus 1 divided by 5%, and all of these we multiplied them with 1 plus 5%, and we get $3,310.12. And the third one is present value of ordinary annuity, and the formula is present value equals cash flow divided by R multiplied by 1 minus, between brackets, 1 divided by 1 plus R to the power of n. An example given: what amount should you invest today at 5% if you want to have $5,000 at the end of each 5 years? So we apply these numbers to the formula. Present value equals 5,000 divided by 5% multiplied by 1 minus 1 divided by 1 plus 5% to the power of 5, because it's 5 years, and we get $2,164.73. And the final one is the present value of annuity due, and the formula is present value equals cash flow divided by R, which is the interest rate as I mentioned before, multiplied by 1 plus R to the power of n minus 1 divided by R, and all of these multiplied by 1 plus R. An example given: PV equals 5,000 divided by 5% multiplied by 1 plus 5% to the power of 5, because it's 5 years, minus 1. All of these divided by 5%, and we multiplied all of this with 1 plus 5%, and we get $508,191. Mixed stream. Mixed stream cash flows are when you receive different amount of cash flows each year, not a steady cash flow. Now I will calculate the future value of mixed stream. For example, if you expect to receive the following mixed stream of cash flows over the next 3 years, and you expect to receive 8% on them, how much will it accumulate by the end of the third year? And we have, for the first year, cash flow is $11,500, and for the second year the cash flow is $14,000, and for the third year the cash flow is $12,900. We can use the general formula of future value, which is future value equals present value multiplied by 1 plus R to the power of n. Looking at the timeline, on the first year we calculate the amount for the next 2 years. So from year 1 to the year 2 to year 3, which is 2 years. So the calculation is future value equals 11,500 multiplied by 1 plus 8% to the power of 2, which is the 2 years we calculated before, and we get $13,413.60. And on the second year we calculate the amount for the next 1 year. So from year 2 to year 3, the calculation is future value equals 14,000 multiplied by 1 plus 8% to the power of 1, which is the 1 year we calculated before, and we get $15,120. And for the third year we calculate the amount of the same year. So the calculation for this year is future value equals 12,900 multiplied by 1 plus 8% to the power of 0, which is the same year, and we get $12,900, and we sum up all of these numbers and we get $41,433.60, and this number is the future value. Also, we can calculate the mixed stream of the present value as we calculated the mixed stream for the future value. So if you are promised to receive the following mixed cash flows over 3 years and earn 9% on these investments, how much should you pay now for this opportunity? So for year one, we have $400 cash flow, and for the second year, we have 800 cash flows, and for the third year, we have 500 cash flow. Also, we can use the general formula of present value, which is future value divided by 1 plus r to the power of n. And in this case, we calculate backwards. So we start with the third year by calculating the amount of this year and the previous 2 years. So the present value equals 500 divided by 1 plus 9% to the power of 3 as we calculated before, and we get $386.09. Then we calculate the amount on the second year for this year and the previous 1 year. So we have the period is 2. So the present value equals 800 divided by 1 plus 9% to the power of 2 as we calculated before, and we get $673.34. And finally, we calculate the amount of the first year. So we have only 1 year. The present value equals 400 divided by 1 plus 9% to the power of 1 as we calculated before, and we get $366.97. And we sum up all of these numbers that we got, and we get $1,426.40, and this will be the present value. Loan amortization. The principal of the loan is paid down over the life of the loan. A loan amortization schedule is a schedule of equal payments to pay a loan, and the formula for the loan amortization is cash flow equals present value multiplied by interest rate divided by 1 minus, between brackets, 1 divided by 1 plus r to the power of n. And we begin calculating loan amortization by finding out the size of the payment. So, for example, if we have $6,000 principal and 10% interest rate over 4 years repayment period, we apply these numbers to the formula. So cash flow equals 6,000 multiplied by 10% divided by 1 minus, between brackets, 1 divided by 1 plus 10% to the power of 4, and we get $189,282.48. Now we will start with a loan schedule. So on the first year we have a beginning principal of $6,000, and we already found the loan payment, which is $1,892.82. And to find out the interest, we multiply the interest rate by the beginning of year principal. The interest rate is 10% and the beginning of year principal is $6,000, so we get $600. And also, to find out the principal, we deduct the interest from the loan payment. So the loan payment is $1,892.82 minus $600, and we get $1,292.82. And also, to find the end of year principal, we deduct the principal from the beginning of year principal. So the principal is the beginning of year principal, sorry, is $6,000 minus $1,292.82, and we get $4,707.18, and we use the end of year principal as a beginning of year principal for the second year, and we do the same thing for each year up until we pay the loan.